Let me start presenting myself. So, I work as an assistant professor in theoretical physics. Why I'm mentioning this? Because yesterday I was giving a talk at the Yukawa Institute in Theoretical Physics in Kyoto, talking about black holes. And sometimes people ask, why and how is it possible to move between so different topics? Well, the point is the following. In my work, I try to apply physics to the blockchain, physics to the crypto market. Why? I also use machine learning. But when you use physics, when it's possible using physics, you understand the nature and the motivation of the phenomenon that you are observing. When you use machine learning, maybe you have a perfect fitting, you see a perfect behavior. It's great. As I said, I use it. However, you don't understand any motivation. So every time it's possible, I prefer use physics. Now, this is also the main content of the presentation here. However, I will skip technical details and I will provide references. Before starting, allow me also to say that I'm here on behalf of Cryptonary. I need the pointer. Thank you.
The green one up here, and then red is back.
OK, thank you. Sorry, I'm here on behalf of Cryptonary. So I will tell you about what Cryptonary is and what's my role at Cryptonary. And then I will move toward this topic. How is possible to predate the bear, to predate panic selling by using physics, in particular by using the theory of phase transition. Phase transition are, for instance, when you when you warm up water and moves from liquid to a vapor state. Here, we will use the same concept in a slightly different way. So, let's start. What is Cryptonary? Cryptonary is a research platform whose goal is extracting information from the whole noise that is present in the crypto space. For instance, fake news, opinions, trustful account, less trustful account. So the goal is to clarify things and to provide insights about the market to subscribers and to the users. It's a community. The main goal is providing reports, and in these reports, if you subscribe to the platform, there are different levels of subscriptions. You can find different levels of reports that allows you to understand a little bit better specific topic. There are also podcasts, there are also very deep discussions about meme coins and other super cool other stuff. Also, there are social events happening in this time, like for instance the US election that probably affected the crypto market as well. There are other phenomena that we can find analyzing the behavior of investors and so on. So Cryptonary has a team of analysts trying to collect all this information from the society. So not only considering the markets, but considering also what's outside the blockchain sphere to understand if there are interactions. Provides a comprehensive range of services, here summarized as follows. For large enterprises that are seeking in-depth crypto market insights and strategic advice driven by metrics, new metrics, proprietary metrics, and so on. Services to small companies that want to use a blockchain, they want to introduce the blockchain in their process or in the process of their customers. Then provide services to single individuals that maybe want to learn or want to invest a limited amount of money, at least at the beginning, in the crypto market. And also, as I was saying, is a trusted community. So really, it's also about to launch a mobile application that is going to be very cool. A few words, again, about Cryptonary. So it's headquartered in Dubai. From the 2017, has grown into a global team of about 50 professionals collaborating mainly remotely from all over the world. We currently boast over 210,000 regular subscribers, and let me say our impact in the very last 12 months that, in my opinion, are impressive because we reached more than 506 million content impressions across platforms like X, like IG, Reddit, and so on. And also we had more than 120 million of unique individuals engaging with our content. It's amazing. My role at Cryptonary is running a research lab, and the goal is to define new perspective on on-chain data analysis, new metrics, and market modeling to support analytical reports, alpha strategy implementation, blockchain education, use case scenario, and so on. And the approach is deeply data-driven. And as I was mentioning, is first based on physics and maths. And we are also opening to the area of quantum computing that is going to be the next high wave in computation. Now, we are expanding, so let me just very, very quickly say that we are looking for new talents. In particular, what we look for? We look for ambition, both students and professionals, that want to join us in challenging adventure in a dynamic environment. Independence, taking the ownership of a project, of a task. Team spirit, collaborating, and the passion. We seek for true passion for the crypto market, for the crypto space. What are the technical skills I look for when I analyze a CV? In particular, I look for people with an experience in data science first, machine learning and AI, quantitative methods, agent-based model, and again, blockchain development. So after this introduction, I think I'm ready to move toward the topic, the main topic of the presentation. Sorry, if you are interested, feel free to send me an email with your CV attached if you want. I'm more than happy to discuss with you about all the possibilities that there are currently at Cryptonary. So, on-chain data analysis. Why on-chain data analysis? Because on-chain data contains user behavior. And if we understand user behavior, probably we understand the crypto market because it's made by humans, okay? I'm going to refer to the BTC, to the Bitcoin blockchain in this talk. However, this applies also to other chains, but for simplicity only to the BTC blockchain. And what are on-chain data? On-chain data are data included in the blockchain. In each block, we have transaction, but we have also other parameters like the timestamp, blockade, number of transactions, and each transaction is structured in a way so we have input, output, there is a fee, and so on and so forth. Our goal is not considering all these parameters, but only those that can be connected somehow to the user behavior. In my view, as a physicist, I think that every system in nature has a sort of code. Life is encoded in DNA. In the case of the crypto space, I think that blockchain constitutes a sort of DNA for the crypto market, and I'm going to show why I think that. So we have two systems. On one end, we have the blockchain. On the other end, we have the time series. And the goal is to see if there is a dynamics from the blockchain affecting the crypto market, because we are saying that constitutes a sort of DNA. And we want also to measure these interactions. There is an underlying community. In this community, the crypto space community is composed of wallet owners, miners, speculators, investors, and many others. Although, in this topic, and for this result that I'm going to show in, I'm not relying on this community. Okay? I'm just considering the two systems and the data they both contain. How can you explore the relationship between such two different systems? In one case, you have blocks with parameters. In the other case, you have the time series with the price fluctuations. So there are some steps. Avoiding technicalities again, we have to turn the blockchain into a time series or the crypto market into a blockchain. And I think that is more natural, try to transform the blockchain into a time series. And I'm going to show you how. First, finding a suitable data space, and then using this point representing blocks in this data space to build up a time series. The approach is the following. As I mentioned, I'm interested in the parameters related to the user behaviors. And the most important ones are the number of transactions, the number of inputs, and the number of outputs. So we extract an arrow, let's say, that is composed of these components. And these arrows in math are called vectors. So since these arrows are connected along a chain, what we have after this transformation is a one-dimensional vector chain. You can imagine the Cartesian plane in 3 dimensions where you have x, y, and z, and substitute those 3 labels with the 3 parameters. Okay? So for each block, you are able to identify a point in space or an arrow pointing to that point, a vector. Well, if we analyze each single parameters, we see that there is some evolution. There is a dynamics. And I want to see if we combine these three parameters together, if we can detect some relevant events in the crypto market. Also, these parameters can take different values. For instance, one block can contain, I don't know, 100 transactions, another block 1,000 transactions, and so on and so forth. So there is a so-called phase space containing all the possibilities that we have in the data space considering these three parameters. And what we observed that is, I think, amazing, is that the phase space of the blockchain is very, very compacted, meaning that on average, all blocks tend to be very, very similar. You can visualize these as arrows pointing on average toward the same direction. It doesn't matter the direction, but all pointing on average toward the same direction. So more or less same amount of transaction in each block, same amount of input, same amount of output. We call in physics this state a state of order. And it's important because I'm going to recall this later. Well, now there is an equation, but we can avoid again the technicalities. There is, in particular, an Hamiltonian. Hamiltonian is used in physics in order to quantify the energy. However, the point is the following. We fit with our vectors this function, and we obtain a point for each time. Okay? Accordingly, we have a time step. So after this transformation, we started with the blockchain, and we had a time series that I refer to as H, or dH. dH is just the time derivative, the variation in time of this time series. First, we look at the time series for understanding the meaning of these peaks. For instance, the main one refers to the flood attack happening in the 2015, and it's amazing. Why? Because it means that after transforming so deeply the blockchain into a time series, considering only three parameters, those related to the human behavior, we are still able to detect information inside the blockchain, and this is amazing. Now let's move to the crypto market. We could use, in principle, the time series coming from the price fluctuation, but it's not that convenient because the range is very high. So there is a function that is called hold time I that is more convenient because it allows to bound the time series between 0 and 1. How is it worked? It's just the price at the given time divided the maximum price the token had so far. So you bound between 0 and 1 the Bitcoin price, and you have a time series that is much more easy to deal with. Now we have two time series. The first one is the blockchain, the second one is the all-time high. So what we want to do is try to infer causal relationship between the two time series, but this represents a very complex and old problem. And we did that just relying on statistics and dynamical system theory. Again, in order to avoid technicalities, I'm just going to show you the statistical approach based on the Granger causality test. Why that? Because I want to see if the dynamics occurring in one time series are somehow affecting the dynamics into the other time series. So this is the motivation of this analysis. The Granger causality test works this way, in simple words. You have two variables, our two time series, let's say x and y, and you compare the forecasting quality of one variable using an ARMA model, and then you compare the outcome of this process by using also the other variable, the other time series. If the p-value that is a relevant parameter for this test is smaller than a given threshold that is equal to 0.05, the test is successful, otherwise it fails. According to the Granger causality test, there is a causal relationship from the blockchain to the crypto market, but it fails from the crypto market to the blockchain. Dynamical system theory instead suggests that there are also interactions in the other way, and I'm going to mention that later. Now, here we have the hold time I, with some red dot indicating events where the Bitcoin lost at least the 10% in value. Why are they relevant? Because they have been detected by using the blockchain time series. How? Using in particular, the time derivative, removing small fluctuations and just considering the main peaks. Well, each peaks predate of 21 days a panic selling of at least 10% in the crypto market for the BTC. What's the meaning of this peak? I said at the beginning that all blocks tend on average to be the same and looking as a state of order, or arrows aligned into the same direction. When we have these peaks, arrows are pointing in random direction. They are not coordinated, and we call this state disorder. So we have at all the effects a phase transition from order to disorder, enabling us to detect a relevant event like panic selling in the market. This is amazing, I think. So we connect disorder in the blockchain with the panic in the crypto market, leveraging principle from theoretical physics. I really like that. I really hope you like that too. Because really there is no machine learning here. It's just based on physical principles. Now, let's study the other way. So if we have the crypto market sometimes affecting the blockchain dynamics, the way investors, if investors are able or not to affect BTC owners doing transactions daily. In order to study this, there are two steps. The first one is finding a data space, again, but we can use the very same that is based on the three parameters. As I was saying, the number of transactions, the number of inputs, and the number of outputs. And then we map this action into strategies, because I want to observe what people are doing. And when I want to quantify what people do, I like to think in terms of strategies, so a sort of game theory. To do that, we devised a model, an agent-based model, very, very simple. In particular, we studied the model where there are strategies composed of three components, taking random values, again, with the phase space, in order to be as much similar as possible to the real-world case scenario. And then the payoff, that is the gain associated to each strategy, depending on a parameter, here indicated as lambda. For small values of lambda, you can see that there is almost a flat line on the top, while for higher values of lambda, you see that the decrease in value is much faster. What's the meaning? It means that if the decrease is very slow, more or less all strategies tend to have the same gain, the same payoff. Accordingly, if you are dealing with smart people, with rational people, it doesn't matter if they play according to one strategy or the other. Instead, if we have a strategy distribution, a payoff distribution, different, where some payoffs are higher, much higher than others, rational people are going to use, on average, more beneficial strategy than less beneficial ones. Using this model, also, there is a probability distribution that depends on a parameter called temperature or noise, that again is used in physics and in information theory, such that you can tune the payoff distribution, and we can control at all the effect the behavior of our agent. So it's let me say that it's a very, very simple model where we can control the agent behavior. When we have strategies, all of them having the same payoff, agents do not care about the strategy. They just pick them randomly. When there are strategies with a higher payoff than others, they lean to take those more beneficial. Now, how to quantify the variations of strategies selected by our community of agents in our simple game? By using a parameter, again, taken from physics, that is called entropy. Entropy, people say that refers to the disorder of a system. I prefer to say that it quantifies the degrees of freedom of a system, okay? So the higher the entropy, the higher the amount of selected strategy. The lower the entropy, the smaller the amount of selected strategy. If we just at some point, we manually change the system so that there are only few strategies, what you observe is a sharp drop of the entropy. Here there are many strategies. Here there are very few strategies selected because only few strategies lead to a high payoff, to a high gain. Let's move now to real data to see why I'm discussing this model. Because if we compare simulation in our agent-based model with the real data from the blockchain using the vectors composed of the three parameters, number of transactions, number of inputs, and number of outputs, we observe a very similar behavior at the beginning in particular, at the beginning when the blockchain was invented. I mean, at the beginning, as you can see, the entropy was very high because Bitcoin was worthless. So everyone was just sending Bitcoin among the wallets without taking care too much. It was like a game. At some point, after the Bitcoin Pizza Day and after launching relevant transaction on the first exchanges, the situation changed drastically. As you can see, there is a sharp transition. The very same sharp transition we are able to repeat here. The very same phenomenon. Again, it's amazing because something happened, something drastic happened. So our question was, what happened? We compared this behavior with the price dynamic. And what we figured out was that actually the sudden drop in the entropy was highly correlated with the events of having large-scale Bitcoin exchange, first real-world transactions, although the value of Bitcoin at the time was smaller than $1, but higher than zero. So Bitcoin users became much more careful about their token as soon as their token was worth like $0.1. Even a small value, they changed completely behavior, and this is amazing. So this is a proof that in some sense, also the crypto market is able to affect the people behavior. So this is expected, I think, but I'm proud to say that we measured with data this phenomenon by using a very simple game. I want to thank also my collaborators, my academic collaborators, and here there are references if you are interested in knowing the technical details of my talk of today. The first one, Disorder Unleashes Panic in Bitcoin Dynamics, and the second one, The Rise of Rationality in Blockchain Dynamics. The first one relates the panic selling and the disorder in the blockchain. The second one instead relates the agent-based model to understand the interaction from the crypto market to the blockchain. Thank you for your attention, and here there must be my email was, okay. There is a missing slide.